Hello and welcome to the hidden world of microorganisms. Today we are going to explore soil. This might come as a surprise to you, but soil is much more than just a support for our feet. In ancient Hebrew, soil was called Adamah, which also gave the name of the first man in their and others' religions, Adam. The word human derives from humus in Latin, which is the name of a soil very rich in organic matter. This shows how in ancient times people already knew how strong and important the link between us and our societies and the soil are. Nowadays, most of us worry about the soil only when it is a sandy beach by the seaside. But actually, there is much more going on under our feet constantly, wherever we are. During my PhD, I found out that in 1 gram of soil in the floodplain where I was working, there were 200,000 traces of species, of different species. If we try and count the number of species that we know, cats, dogs, cows, earthworms, baobab trees, insects, etc., I think we could come up with a few hundreds, maybe 1,000 of species. So 200,000, it's a lot of species, and 100 grams of soil is very tiny. So what is the soil then? Soil develops between the surface of the rock, of the earth, and the atmosphere or water in some places. With rain from top and seasonal temperature changes, and even the movement from deep down in the earth, the basal rock slowly, very slowly crumbles. From the top comes organic matter from dead organisms or waste from the living ones, and this organic matter comes together with what we call inorganic matter, the one that comes from rock, and mix in what we call soil. Soil can be a very thin layer. For example, on top of mountains, when there are no trees and submitted to strong wind, it can be blown away, and also rock tend to crumble down or slide down. But in some places on Earth, soil can be very thick, like 8-9 meters deep. Soil is home to many organisms. Most of them are microorganisms, but many are also bigger and maybe you are more familiar with, like moles, mice, earthworms, beavers, insects, fungi, rabbits, spiders, and of course also plant roots. The inorganic part of soil, the one originating from the rock, is divided in 3 components based on their size, the size of the particles of rock basically. And those 3 components are called silt, sand, and clay. The smallest particles are called clay, and they are smaller than 2 micrometers, which means smaller than 1,000 of 1 millimeters. Silt is bigger than clay, but it's still smaller than 1/20th of a millimeter, which means that we still cannot see it with the naked eye. We need at least a magnifying lens to be able to see 1 grain of silt. And the biggest particles are called the sand, which obviously we can see with the naked eye. But they are still smaller than 2 millimeters. Different types of soils are defined by the different proportion of clay, silt, and sand, and this classification of soil is called texture. The texture of soil, the different particle size, are extremely important, not only for the different characteristics they present, but also in the way they influence the organisms that can live in it. For example, very sandy soil have a very small water retention capacity, which means that water passes right through it, and with it flow away all the nutrients as well, which make for a very poor soil. No wonder that no organism or very little organism are able to live in it or even on it. On the other side, a soil very rich in clay will retain a lot of water and might become too muddy or too watery for organisms to live in it. The problem with clay is that its particles are so tiny that when they are pressed together, they don't leave much space for air to circulate. In fact, if they are pressed together and baked in an oven to make evaporate all the water it contains, it becomes quite hard. It's because it is used for pottery or even to build bricks. People have used bricks to build their house for thousands of years. But most organisms need a combination of clay, silt, and sand to be able to live in it. When the proportion of clay, silt, and sand is perfectly balanced, we call it loam. Depending from the basal rock underneath the soil from which the inorganic part of the soil originates, the content of mineral and nutrients in the soil will be different, and that will strongly influence the type of organisms that can live and survive there. In turn, the community of organisms will also influence the soil in which they live. For example, let's talk about roots. For a start, roots can give stability to a soil, protecting it from being blown away from the wind or even slide down with water. Plants, especially trees, also pump a lot of water from the soil up to the leaves where they release it into the air. And roots also release the organic matter into the soil around them, which feeds many microorganisms. Small mammals like rabbits, moles, mice, or even insects or earthworms, by digging their burrows, they improve air circulation deep in the soil, which can help the survival of a huge community of microorganisms. Also, they tend to bring organic matter down there with their food and the food residues they leave behind or the wastes, and that also contributes to the maintaining of the microbial community, which is important to maintaining a healthy ecosystem functioning. Soil texture and nutrients content influence the community of organisms, which in turn influences the soil. But there's another main factor that comes into play, and that's the weather. The amount of sun, of rain, the winds, the changing temperatures, the season, they all influence the soil composition and the community of organisms. This is it for today. I hope you enjoyed learning a bit about soil and that you will continue following me in this journey of discovery and amazement. Bye now!